What's up, guys? It's Dan from sagemathtutoring.com, and this is another video pertaining to relatively advanced trigonometric equations and such. And this is based off of a homework assignment that one of my students has, and I'm going to call this video the Trigonometry Homework from Hell video. All right, so hope you like it, and hopefully it's helpful to some of you who are dealing with this stuff. So the first problem on this homework assignment says to simplify this guy right here. All right, now clearly the first thing that you're going to notice is that it's not just a theta here, it's a 3 theta, it's a 3 theta over here. And this right here could be a little bit confusing. There might be a temptation to turn this into like an addition scenario where it's like 2 theta plus theta times cosine of 2 theta plus theta, and then use the addition formulas for these separately, which would expand this into this huge thing, and then that would get expanded even more. And at a certain point you might realize, you know, it seems like we're doing the opposite of simplifying this. It seems like we're actually making it more expanded. I did make that mistake recently. And as it turns out, this is a lot easier than that. And it's so easy that I ended up kicking myself when I realized what was going on. And it has to do with this equation right here, for sure, where we know without question that sine of 2 theta equals 2 times sine theta cosine theta. All right, this is something that your teacher will probably give you on a reference guide. You know, maybe they'll be on the mean side and make you memorize it, but this is an identity that's really helpful, and it's a double angle identity. So sine of 2 theta equals this. Now, it's most of the time, most problems you're going to get, you're probably going to start with something like this, and then you're going to be asked to expand out into this. However, in this case, we're going to start here, and we're going to condense it to this. So you might notice that this looks very similar to this, right? I mean, it's like 2 sine of some angle times cosine of some angle. That same angle. Well, this is 2 sine of some angle times cosine of that same angle. So therefore, we can absolutely right away turn it into a variant of this right here. So in order to kind of make them match up, I'm going to have apples matched with apples. We could absolutely set this equal to sine of something, right? Well, the question is sine of what? Well, this says sine of 2 theta. In other words, sine of 2 times whatever the angle is. Sine, here's the angle theta, and this is going to be sine of 2 times whatever that angle was. So this is going to be sine of 2 times whatever this angle is. So 2 times 3 theta is most definitely 6 theta. So let me just write that in here. And honestly, that is all she wrote. That is all you need to know for that problem, believe it or not. So that's how you do that one. All right, the next one is cosine squared 4 theta minus sine squared 4 theta. And we want to know what does that simplify into. Very similar to the last problem, this relies on your ability to recognize that cosine 2 theta equals cosine squared theta minus sine squared theta. Okay? And similarly, this side of the equal sign really resembles this. All right, so we're going to do a very similar process where we're going to compare apples to apples, and we're just going to set this equal to something over here that corresponds with this. So this is going to be cosine of 2 times whatever the angle is. Well, the angle over here is theta. So we're definitely going to have cosine of 2 times whatever the angle is. And the angle is 4 theta. So therefore, it's going to be 2 times that, and therefore it's going to be 8 theta. And that right there, believe it or not, is your answer. Okay, so the next one is cosine squared theta over 2 minus sine squared theta over 2. Okay, well, guess what? This is a hell of a lot like the problem that we just did, where we had made a mental note that cosine of 2 theta is equal to cosine squared theta minus sine squared theta. And in this case, this corresponds once again over here, right? So we're going to do the exact same process where we're going to set it equal to cosine of something, right? Cosine of 2 times whatever the angle is. So this is going to be cosine of 2 times whatever the angle is. Well, what's the angle? The angle is theta over 2. Theta over 2. 2 times theta over 2 would result in the 2's canceling out and leaving you with just theta. So that right there is the answer to this one. This simplifies into cosine theta. The next problem is 2 times sine of theta over 2 times cosine of theta over 2. So this has to do with the first problem that we did earlier, where at a certain point it might behoove you to memorize or become familiar with the fact that sine 2 theta equals 2 times sine of theta times cosine of theta. Clearly, in this case, this part matches this part. And we're going to have, therefore, a very similar situation where it's going to be sine of something. Well, what is that thing? It is going to be sine of 2 times whatever the angle is. Well, what's the angle? Theta over 2. And just like on the last problem, we realized that the 2's would cancel, leaving only theta. So that's the answer to that one. All right, so on the homework assignment, we have our first equation. And this equation is tan squared theta minus 4 times 2 times cosine theta plus 1 equals 0. So basically, you have some number times another number equals 0. So that therefore means that if this whole thing was a 0, then it would be 0 times whatever the hell that is, and it would be 0. If this whole thing was a 0, then it would be 0 times whatever the hell that is, which would be a 0. So what we could do is we could set up 2 separate equations and literally force each of these equations to equal the 0 that we kind of want it to be, and then solve for theta. All right, so 2 separate equations, set equal to 0, and then finding out what theta is. In other words, what theta would cause this whole thing to equal 0. What theta here would cause this whole thing to equal 0. Tackling the top one first, adding 4 to both sides, we'd end up with tan squared equals 4. And then perhaps taking the square roots of both sides. Don't forget the plus minus, and you're going to end up with tan of theta equals plus minus 2. So basically, we can't really use the unit circle for this because you're not going to be able to find the angle, the tan of which would give you a positive or negative 2 over here. However, you can definitely plug that into your calculator, and even on the homework assignment, the directions say round to 3 decimal places, which is sort of a clue that we're going to be using our calculators for this stuff rather than the unit circle. I'm still going to leave the unit circle here just in case. But essentially what you're doing is finding the inverse tangent of, we could say plus minus 2. And we're going to find out, what is that? Well, the inverse tangent of positive 2, for sure. Let me actually just get this out of the way right here. The inverse tangent of positive 2, when I put it into the calculator, is going to be 1.107, and it's to be rounded to 3 decimal places. So actually, that would do it right there. So it's going to be 1.107. I'm curious to see if we're going to get a different angle. We probably are when we figure out the negative 2. So I'm not going to change it to inverse tangent negative 2. And actually it just gives the negative version of that same number. All right. So that is a step in the right direction. However, tan has a period of pi, so it's important to also include plus pi k. And same with this. So that right there is how you do that one. Now, of course, let's not forget the other formula that says 2 cosine theta plus 1 equals 0. And let's kind of break this down. By subtracting 1 from both sides, we'll end up with negative 1. Dividing both sides by 2 would give us a negative 1/2. This one right here, we can actually use the unit circle. Keeping in mind that cosine of theta cosine corresponds to the x-coordinate when you're dealing with the unit circle. So we're looking for the x-coordinate, angles that have an x-coordinate of negative 1/2. So clearly we're not going to be in quadrant 1 or 4, we're going to be over here. So we're definitely looking at 2 pi over 3, and we're looking at 4 pi over 3. So the theta equals 2 pi over 3 and 4 pi over 3. Let's see. Enter answers as comma separated list. Let k be any integer round to 3 decimal places. Yeah, so we're not going to round to 3 decimal places because we have the pi's here, and therefore this is actually a more precise expression of what the angle is than if we plugged it into a calculator. So when you're using the unit circle, you could go ahead and just use the angle that's presented in the unit circle. You don't have to plug it into your calculator and round it to 3 decimal places. That's one of the nice things about the unit circle. It's like a quick tool that you can use to find the exact angle. But anyway, according to the teacher wants the answers. I probably should have done this for the last one, but whatever. Enter the answers as a comma separated list. Let k be any integer. Okay, so let's focus only on 2 pi over 3 for now. We know for a fact that cosine as a function has a period of 2 pi. So that's going to be 2 pi over 3 plus 2 pi k. And this other angle that features the x-coordinate of negative 1, which is 4 pi over 3, that is also going to be represented with that 2 pi k. All right, I believe this would satisfy the teacher. In fact, I might not have done this in the last one either, but you might want to represent your final answer as theta equals whatever the thing is. All right, something to keep in mind. All right, so the next one is 3 tan to the third theta equals tan theta. Now, I think there might be a temptation to just be like, divide both sides by tan, and then you'll end up with tan squared theta equals 1. But, you know, I'm a little skeptical of that approach because, you know, by canceling one of these tans up here, you might be losing information. So I'm going to advise approaching this in a somewhat different way. So let me just rewrite that. So we're dealing with 3 tan to the third theta equals tan theta. I'm going to, this sort of reminds me of like a quadratic equation. So I'm going to subtract tan from both sides. So I'm going to end up setting this equal to 0, in other words. So let's see what happens when we do that. So we set it equal to 0. Now we can sort of look for the GCF, and the GCF, greatest common factor in this case, would be tan. So we could take a tan out, and inside we'd have 3 tangent squared minus 1 equals 0. And that lands us in a similar situation as the last problem, where you just have some number times another number equals 0. So therefore, if this whole thing equals 0, then 0 times whatever the hell this would be 0. If this whole thing equals 0, then it would be 0 times whatever this is would be 0. So you could then, of course, set up 2 separate equations. And first equation would be tan theta equals 0. And the second equation would be 3 tan squared theta minus 1 equals 0. Focusing only here, the tan of what angle would give you 0? Okay, so this happens to be something that you could use the unit circle for, because just keep in mind when it comes to tan is always going to be y over x. If you're using the unit circle, tan corresponds with y over x. So for my student at home, if that's not easy to remember, I don't know, find a way to associate tan with rise over run, because this is kind of like y over x. It reminds me of the slope equation where it's like y2 minus y1 all over x2 minus x1. So maybe that's helpful. Maybe that's more confusing. I'm not sure. You might have to just memorize it. Anyway, if we're going to recognize that tan corresponds with the y-coordinate being over the x-coordinate, well, the only y over x ordered pair that would result in a 0 is, let's see. It's actually 2 of them, right? It would be this one and this one, right? Because over here, it's definitely the case that y over x would be 0 over 1, and that would be 0. And y over x here would be 0 over negative 1, and that would be 0 as well. Now the good news is we can just name like one of these angles and just say plus pi k, because it's like plus pi would land you here anyway, plus another pi would land you here anyway, plus another pi would land you here anyway. So I'm going to say for this one, the way to think about it would be something along the lines of like 0 plus pi k, because this angle 0 corresponds with a y over x that would give me a tan theta of 0. All right. Now I could have also said, you know, 2 pi plus pi over k. All right. But the reason why I'm saying 0 is because I can then go ahead and just simplify it even further and literally just call it pi k. All right. You know, which angles would result in the tan of theta being 0? Well, you know, any multiple of pi, essentially. All right, including k being 0. So Good. That's one of the answers. As the final answer, we're going to list them in commas like the teacher was asking for, but for now, we have that. All right, this one, we've got 3 tan squared theta. If we add 1 to both sides, we're going to have that. Then we have tan squared theta. It's going to equal 1/3, so we're going to divide both sides by 3. And then after taking the square roots of both sides, we end up with tan theta equals plus minus the square root of 1/3. All right. So, you know, in the calculator, I could just sort of treat these separately. I could investigate one at a time. It's like the tan of, we could say arctan of radical 1/3. And we could also investigate the arctan of negative radical 1/3 and see what happens there. So I'm going to calculate that right now. Okay, so I calculated it, and I ended up with 0.524 for this one and negative 0.524 for this one. Now, we do want to keep in mind that will be plus pi k, because tan has a period of pi, so that's going to be plus pi k as well. So at the end of the day, the final answer would be theta equals pi k as one of the answers, comma, 0.524 plus pi k, and finally negative 0.524 plus pi k. So that would be the final answer for that one. Alright, so the next problem says 6 sine squared x minus 6 equals negative 5 sine x, and the directions say give the general solution, use k when writing your general solutions. Well, it's very similar to the last directions, actually. So with this one, I would definitely set up the quadratic. I would get it to look like a quadratic trinomial by adding 5 sine x to both sides. And we end up with this scenario. This is a perfect scenario for u substitution, where we could call this 6u squared plus 5u minus 6 equals 0. Now, when you're using u substitution, it's just a way of putting this in a more familiar looking scenario so that you could easily like factor it or whatever. And if you're going to use u substitution, remember the u corresponds with whatever the middle term variable is. All right. So anyway, here we go. Let's see if this is factorable. One way of checking to see if it's factorable is to multiply this coefficient times this constant, and ask yourself if that magic number, in this case it would be looks like it would be a negative 36. You ask yourself if that magic number has any factors that could add up to positive 5. And I am seeing absolutely. A 9 times a negative 4 would most definitely give me a negative 36, and a 9 plus a negative 4 would most definitely give me a 5, right? So, in other words, we found out that this magic number that we got from multiplying these guys, I don't know where I'm going with that. So this magic number that we got from multiplying these guys has factors that add up to the middle term. And that's the way to know very quickly if something like this is factorable. All right, so we're actually going to take advantage of that information that we just discovered. That negative 36, and by the way, this should have been negative 36 over here. This should have been negative 36. But You get the point? We have on our hand 6u squared plus, and we're going to explode that middle term. And what are we going to put there? We're going to put 9 minus 4 there. Okay, we're going to put those two factors that we knew would multiply together to give us a negative 36. And then you distribute this u into these guys. And then we're going to do factoring by grouping. So the reason I'm kind of moving quickly through this is because I did a lot of this stuff on the last video. So hopefully, to my student at least, this factoring by grouping stuff should be fairly familiar. At this point, you're going to focus on one pair of terms at a time. Focusing on the first pair, what's the GCF? Well, that would be, looks like it would be 3u. So you take out a 3u, you're going to end up with 2u plus 3. All right, you can always double check and just be like, all right, 3u times 2u, does that give me a 6u squared? Yes. 3u times 3, does that give me a 9u? Yes. When it comes to factoring by grouping, it's always going to be the case that this parentheses is going to be perfectly matched over here. All right, if you know that it is indeed factorable, then you know that that's going to be the case. So you just go ahead and just write it there. And then you ask yourself, what times 2u would give me that negative 4u? Well, that would be a negative 2. And you can always double check. Does negative 2 times positive 3 give me a negative 6? Yes, it does. Let's not forget to set it equal to 0. And then you take note of what the MVP parentheses was. The MVP parentheses, the most valuable player, is 2u plus 3. So we just go ahead and write that on the next line. And what are you going to write next to it? An empty parentheses. What goes in this empty parentheses? Well, everything else up here that was not 2u plus 3, namely 3u minus 2. So that's going to be 3u minus 2, and that equals 0. Now, we're in a similar situation as we've faced with some of the last few problems, where it's like this whole thing was 0, then 0 times whatever this was would be 0, and so on. So we can set up separate equations here. And let's go ahead and just solve for u, and then we'll take it from there. So the first equation would be 3u minus 2 equals 0. And the second equation would be 2u plus 3 equals 0. Focusing on the first equation, 3u would equal positive 2. Dividing both sides by 3 would give me u equals 2/3. And then focusing over here, subtracting 3 from both sides would give me 2u equals negative 3. Dividing both sides by 2 would give me u equals negative 3 divided by 2. Now, at this point, we're going to want to switch the u with sine x, right? Because u is actually equal to sine x. So we know for a fact that sine x equals 2/3. And we know for a fact over here that sine x equals negative 3/2. And then the question is, okay, what angle is such that when you do sine of that angle, you're going to get 2/3? What angle is such that when you do sine of that angle, you get negative 3/2? So I'm going to give myself a green asterisk for this scenario, with the full knowledge that we're going to have to do the inverse sine of 2/3, and that will give us our answer. And I'll also do a little asterisk here, and that's the red asterisk, where we know for a fact we're going to have to do the inverse sine of negative 3/2. And we're going to find out what angle corresponds with that. So I'm going to use my calculator for this one and this one right now. So as it turns out, the inverse sine of 2/3 is 0.73, and the inverse sine of negative 3/2 is undefined. So that means there's no solution over here, so we can just disregard that. Now, when it comes to this, though, we got to remember that sine has a period. Sine functions have a period of 2 pi, so we could say plus 2 pi k. And that would be the answer that the teacher is looking for. And again, maybe you might want to actually write it like this. This might be actually a nice, a little bit cleaner way of writing it to please the teacher, where you're making it very clear to the teacher that you know that basically what this means is that the angle equals this. All right, so the next one is 4 cosine squared x equals 7 cosine x plus 2. This one, similarly, I'm going to want to get it to resemble the quadratic trinomial set equal to 0. In this case, I'm going to have to subtract both of these guys from both sides of the equation, giving me negative 7 cosine x minus 2 equals 0. Similarly, I'm going to use u substitution, where this would be 4u squared minus 7u minus 2 equals 0. And then I'm going to ask myself, is this factorable at all? And the way that I'm going to do it is I'm going to multiply 4 times negative 2, and that gives me the magic number of negative 8. Put a little halo around it. So negative 8 for sure. And the question is, are there any factors of negative 8 that are such that when I add them together, I get a negative 7? And absolutely, if you had a, what would it be? A 1 times a negative 8, well, that would give you negative 8. And if you had a 1 plus a negative 8, well, that would give you negative 7, which is the middle term coefficient. So therefore, this is factorable. And in fact, we're going to take advantage of this work that we already did right now. This time I'm just going to leave it over here. I'll draw a box around it though. This was the analysis of the magic number. And over here, we're going to write 4u squared. And it always do plus. If you're going to do this bomb method where you explode the middle term, on the next line, always do plus and then parentheses. U minus 2 equals 0. And what goes in those parentheses? Well, clearly it's going to be 1 and that negative 8. All right. Then you could go ahead and distribute this into it. And what we end up with is 4u squared plus u minus 8u minus 2 equals 0. Focusing on one pair at a time, factoring out a u gives me 4u plus 1. And since it's factoring by grouping, I know that this parentheses is going to be matched over here if it's factorable, and we know that it is. And then we ask ourselves, what times this 4u would give me a negative 8u? Well, that would be a negative 2. Then you could always double check. Does negative 2 times positive 1 give me negative 2? Yes, it does. You don't have to double check, but if you wanted to. So what do we do on the next line once we've got this going? Well, we preserve the MVP. The MVP is 4u plus 1. You got your empty parentheses over here, set equal to 0. What goes in these empty parentheses? Well, everything here that is not 4u plus 1, namely u minus 2. So that's going to be u minus 2. So now we can set up two separate equations where it's u minus 2 equals 0, and another equation that says 4u plus 1 equals 0. Focusing on one at a time, we would have u equals 2 over here, and we would have 4u equals negative 1 after subtracting 1 from both sides, and then u equals negative 1/4 after dividing both sides by 4. And then we could substitute cosine x back into u, and it would be cosine x equals 2 over here, and we would have cosine x equals negative 1/4 over here. Similar to the last problem, we're going to do a nice asterisk scenario where we know for a fact this is going to end up being cosine, or I should say the inverse of cosine. of 2, and we're going to find out what that is. I'll use the calculator for that, and it's probably going to be undefined, I can already tell. And we're going to be asterisking this one as well. I mean, it's pretty close to it. I don't really need to asterisk it, I guess, but we're going to have cosine, the inverse of cosine, of negative 1/4. That is probably going to yield an answer for us. So I'm going to use my calculator and put the answers where they belong. So it turns out that this definitely was undefined. And we have 1.823 over here. So therefore we could ignore this, actually. We could ignore this guy because it's undefined. That basically means there's no solution pertaining to that section. However, over here we can know for sure, I'll kind of write at an angle, that theta equals 1.823. But don't forget, cosine has that period of 2 pi, so that's going to be plus 2 pi k. Done. Alright, so the next one is cosine squared x plus 5 cosine x equals 3. And just like before, honestly, this is almost like a replica of what we've had to do so far. We're going to create a quadratic trinomial set equal to 0, in this case by subtracting 3 from both sides. And we will use our U substitution right out the gate. So we have an issue now because this is not factorable. Okay, this is not factorable. And the way that I know is because the invisible 1 times a negative 3 gives me a negative 3. And there are no factors of negative 3 such that when added together would give me a positive 5. So that means I have the quadratic formula that I could use, or I could complete the square. Now, I think if it's the case that my student who's watching this is not well practiced at completing the square, I'd rather rely on the quadratic formula because that's a little bit more straightforward. All right, quadratic formula would basically say that u equals negative b, in this case it's u equals negative b plus or minus b squared minus 4ac all over 2a. This is something that should be familiar to anyone who's taken, I guess it would be like algebra 2 or something like that. All right, it should be something that's fairly familiar. Now, what is a? Well, a is the coefficient in front of here, namely 1. What is b? Well, b is the coefficient in front of the second term, namely 5. And what is c? C is the coefficient, or the constant, I should say, that constitutes the third term, also known as negative 3. All right, negative 3 is c. So what I like to do, and this is just me, is rewrite this thing only with empty parentheses instead of letters. I found that that is a really, really good way of avoiding careless mistakes, especially careless mistakes that pertain to the signs. All right, so what goes here? Well, b goes here. What's b? B is 5. Right? B also goes over here. And then we got to ask ourselves, what's a? Well, a is 1, so that goes here, that also goes here, and c is negative 3. So continuing to work this out, we would end up with u equals negative 5 plus minus all the shenanigans that are happening here. So let's kind of look at this. We know that it's 25. You know what? I'm just going to write that, 25. Now, before I go minus blah, 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 I'm going to analyze what's going on here. I can tell that it's going to be a negative 4 times a positive number times a negative number. That's going to give me a positive number. So I'm going to just write plus. And then it's plus what? Well, 4 times 1 times 3, 12. All right. So that's one way of going about it. maybe another way to avoid confusion, I'll present another way of thinking about it. You know, you could do the 25 thing. Like, you could do the 25 thing, that's fine. But then maybe just hold off on writing anything. Know that you're going to write plus some number or minus some number. And then you look at this and you just go, okay, -4 times +1 times -3. That is a -12. So then you just write -12. Okay? That's a nice systematic way of avoiding confusion over here. Okay? So here we go. And then it would be all over 2. Simplifying further, we have u equals -5 plus minus radical 25 minus 12 is 13, all over 2. So therefore, u equals -5 plus radical 3 over 2, or -5 minus radical 13 over 2. So let's replace the u with cosine x. So this is going to be a great problem to rely on the quadratic, or pardon me, the calculator, or the graphing calculator. All right, so there's really 2 equations to deal with. We're going to have the arc cosine of -5 plus radical 13 over 2, which is something I'm going to plug into the calculator. And we're also going to have to contend with cosine, inverse cosine of, make this a little smaller, inverse cosine of -5 minus radical 13 over 2. And we're going to find out what each of these are now using your graphing calculator. So after using the calculator, I ended up getting 2.342 for this and undefined for this. So therefore, this can take a hike. There's no solution to be found there. And let's not forget the period of cosine is 2 pi. So we're going to have 2 pi k right there. And you could always put theta, and that would be the answer. All right, so let's look at the next one. The next one says cosine of 2 theta equals 11 sine theta minus 5. Okay. Well, we have sort of 2 problems out the gate, if you want to call them problems. Number one, we have a double angle here, which is going to require us to use the double angle equations or formula. But we also have 2 different trig functions. Now, it so happens that there is a double angle formula for cosine of 2 theta that says that it's equal to 1 minus 2 sine squared theta. So that means that we could substitute this in for that. Okay, we can substitute that in for that. So let's do that. 1 minus 2 sine squared theta, because I'm already seeing that this is going to be such that we can treat it similarly to what we've been doing, which is to set up that quadratic trinomial. But you can't really do that until you only have one trigonometric function to deal with. Now we're only dealing with sine, which is really good. All right, so let's get, all the terms over here. So we're going to subtract both of these right now, and when we do, I'll worry about the order later. But we had 1 minus 2 sine squared theta, and it's going to be minus 11 sine theta, and it is going to be plus 5. And that equals 0. All right? Again, that's a result of subtracting this from both sides of the equation, canceling it out over here. And when you quote-unquote subtract negative 5, that's the same thing as adding 5 to both sides. All right? If my students were comfortable, you could think of doing it one at a time. Maybe first we subtracted 11 sine theta from both sides, giving us this. And then we had to add 5 to both sides of the equation, giving us this. Maybe that's a better way to think about it. I'm kind of rushing through it. But nonetheless, here we are. We're about to set it up so that it's a quadratic trinomial set equal to 0. But in order to do so, we're going to combine the like terms over here. And we're also going to get it in that sort of descending order of exponent. So we have negative 2 sine squared theta minus 11 sine theta, and then we have what's that, plus, it would be plus 6 actually, equals 0. Now, before I go ahead and do quadratic, factoring or use the quadratic formula or whatever, I'm going to want this leading coefficient to be positive. So we want to get rid of this negative 1 that's kind of lurking in front of it and making it negative. So we're going to divide both sides by negative 1, and in doing so, we really just change the sign of everything. So this becomes plus 11 sine theta. This becomes negative 6, and 0 over anything is just 0. All right, so let's now perform our u substitution move, where it's 2u squared plus 11u minus 6 equals 0. And then we could just double check and be like, all right, is this factorable? 2 times negative 6 is negative 12. Are there factors of negative 12 such that when I add them together, I get a positive 11? Well, yes. That would be, what, 12 and negative 1. 12 times negative 1 gives me negative 12, and 12 plus negative 1 gives me an 11. So I'm going to go ahead and rewrite this, only with the empty parentheses, at least at first, set equal to 0. And what goes in here? Well, that would be 12 minus 1. That would be those two factors that I just spoke of. And then we're going to distribute this here, setting things up for factoring by grouping. We end up with 2u squared plus 12u minus u minus 6 equals 0. All right, focusing on one pair at a time. Over here, the GCF of these guys is definitely going to be 2u. So let's take that out. It's going to be 2u times what? Well, that would be u plus 6. All right. Now, if we're doing factoring by grouping, this parentheses is perfectly going to be matched over here always. And then I can ask myself, what times u gives me a negative u? Well, that would be a negative 1. So you just put it there, set it equal to 0. Now, you could always double check. Negative 1 times a positive 6 gives me this negative 6 also, right? So moving on. And when you're doing factoring by grouping, you preserve what I call the MVP parentheses. You've got other parentheses over here. You've got 2u minus 1, and that is equal to 0. And then you could set up two separate equations. 2u minus 1 equals 0, and u plus 6 equals 0. When you solve this, you're going to end up with u equals 1/2. And when you solve this, you're going to end up with u equals negative 6. Let's put an asterisk here, and we're going to transfer that up here. U equals negative 1/2. Or positive 1/2. Let's replace u with sine. I think we're ready for that now. So that's going to be sine theta equals 1/2, which should be actually very easy to do. And then we, over here, we're going to have sine theta equals negative 6. All right, well, let's look at this one first. The sine of what angle equals 1/2? Well, Sine corresponds with the y-coordinates when you're using the unit circle. So we're looking for y-coordinates of 1/2. Well, clearly, we have a y-coordinate of 1/2 associated with pi over 6. We're also going to have a y-coordinate of 1/2 associated with 5 pi over 6. All right, so that's actually two answers. And therefore, we could just go ahead and write it. It's like theta equals pi over 6 plus 2 pi k because of the period of 2 pi when it comes to sine. And we also know that 5 pi over 6 would work as well, plus 2 pi k. Now, this one, you could always plug it into your calculator. You could do the inverse sine of -6. However, I could just tell right now, this is going to be undefined because the largest number this could be is a 1, and the smallest number this could be is a -1. This is smaller than -1, so therefore it would not work. -6 is outside the range of the sine function. Now, that's something that I know from experience. It's something that my student might know from having graphed the sine function on the rectangular coordinate plane. However, if that's not clear, just know that you could have plugged into your calculator the inverse sine of -6, and you would have gotten undefined. All right, so the next one, 2 sine 2 theta equals 1. According to the directions, we want to find all solutions, and we're finding, so it's a two-part thing. We're going to find all the solutions, which means we're going to do like the 2 pi k shenanigans. That's when you do 2 pi k, that basically means you're literally taking into account every angle that satisfies this criteria in infinity. Right? There's actually going to be infinite solutions if you consider all the solutions. But then, according to the directions, they also want us to find the solutions on the 0 to 2 pi interval, which would constrain what the angles could be. And by the way, this chart tells you, it actually displays that very interval from the angle 0 all the way around to angle 2 pi. So we're going to, take note of the various angles that this theta could be within this range, and just take note of that, take specific note of that. One way or the other, we're going to have to solve this. So let's do it. First, I would want to isolate this sine blah first. Sine, I know it's 2 theta, but if you're trying to solve for the angle that's in here, you might want to at least isolate this part. Okay. Let me say it again. You're going to want to at least isolate this guy right here. Now, how are we going to do that? We're going to divide both sides by 2. All right. And in doing so, we end up with sine 2 theta equals 1/2. Now, there might be a temptation to bust out like the double angle formula or something, but if you did that, you would end up with 2 sine theta times cosine theta equals 1/2, and that doesn't really help us. The smart thing to do is to ask yourself, the sine of some angle equals 1/2. Well, maybe we could just find that angle, right? Why don't we just find that angle? Well, let's see. The sine of what angle equals 1/2? Well, sine corresponds with the y-coordinate, just like we said in the last problem. So it's actually sort of almost the same answer. Pi over 6 would work, and 5 pi over 6 would work. All right. Now, we could therefore write the following. We could say 2 theta definitely equals pi over 6. And since we're looking for all solutions, at least at first, that's going to be plus 2 pi k. We also know that 2 times theta is going to equal 5 pi over 6 plus 2 pi k. All right, this corresponds with the fact that, the sine of some angle equals 1/2. Well, that angle must therefore be pi over 6 because that has the y-coordinate of 1/2. Also, this angle must therefore be 5 pi over 6 because 5 pi over 6 corresponds with a y-coordinate of 1/2 as well, right? And since, again, the directions are asking for all solutions, at least at first, we're going to write plus 2 pi k. Now, at the end of the day, we're not trying to figure out what 2 theta is. We're trying to find out what theta is. So that's really easy, though. All you got to do is divide both sides by 2. So this divided by 2, this divided by 2, and this divided by 2. What would that give us? We'll bring it down here. That would give us theta equals pi over 12 plus 2 pi k. And analyzing this, we're going to use a similar process. Exact same reasoning. We're going to have theta equals 5 pi over 12 plus pi k. So I made a mistake. My student might have caught it. This over here is not going to be 2 pi k. It's going to be pi k. So that's a careless mistake. And why is this just pi k? Why is this just pi k? Because these 2's canceled. So I apologize for that careless mistake. But anyway, here we go. We got this one. And we have this one. Now, let's focus over here. Pi over 12. Where is that? Well, that would be pi over 6 divided in half. Okay? That would be pi over 6 divided in half. So that would be like here-ish. All right. And it's pi over 12 plus pi k. Oh, by the way, we satisfied the first part. We satisfied the first answer where they asked us for all solutions. Literally, these are all solutions. So I should have noted, I'm now moving on to the second part of the directions, where I'm trying to find the solutions on the 0 to 2 pi interval. Meaning, what are the solutions that are just inside this circle? All right. So once again, this is pi over 12. But we know if we add pi to it, that's going to bring us over here, right? Because that would be a full semicircle, and pi is a semicircle. So the question is, what is that angle? Well, if you look closely enough, all right, here's what I'm going to do. Let me remedy this real quick. So basically, draw this again. This is going to be right here, pi over 12. So let's get really clear about that. This right here, it's opening up pi over 12. We also know that if we open this to that semicircle, we're going to land right here. And we know for a fact when it comes to that, that's going to be, a width of pi over 12 down from this line. Okay? I think that's the key insight, where when it comes to this answer right here, where you start with a pi over 12, you still have to take into account that one period of pi would also work for you. All right, so here it is right there. So we're going to have to find what this angle is. So we know that this is going to be pi over 12 down from this pi line. So in order to find out what this angle is, all you have to do is add this little pi over 12 thing to pi, because it goes from here all the way, like from this moment to add pi would bring us here, and then it's going to be an extra pi over 12. So to find the other angle within this range of a full revolution that would sort of correspond with this, all we have to do is take pi and add it to pi over 12. Or I should say take pi over 12 and add it to pi. Now, can't just do that right away because we don't have common denominators. But what you can do is you can give this a denominator of 12 as long as you multiply the top by 12 also. So now we have common denominators. We get to add these two fractions. When you have two fractions with the same denominator, you keep the denominator and you simply add the numerators, and that would be 13 pi. So when it comes to the second answer to this problem, this is the answer that satisfies the first part of the directions, where, you know, pi over 12 plus pi k represents, you know, infinite solutions that theta could be. But now we're going to write the sort of correlated answer that has only to do with the range of 0 to 2 pi. And what we've discovered is that there are really two angles, at least for now, that are definitely in that range, and that's pi over 12, and that's also 13 pi over 12. All right, so you might want to just sort of associate all these guys together. This is the answer that satisfies the first part of the directions. This is the answer that satisfies the second part of the directions, having only to do with the range from 0 to 2 pi. Now, we're going to have to do something similar over here as well. So before, the first part of the directions led us to this answer, 5 pi over 12 plus pi k, which takes into account infinite angles that theta could be. But now we're going to constrain the answer in this range right here. So let's start with 5 pi over 12. Where is that? Well, that might not be immediately obvious because it's not like on the unit circle we have anything labeled 5 pi over 12, right? But, you know, a decent way to go about that one is to know that, you know, 6 pi over 12, if you think about 6 pi over 12, that would most definitely reduce to pi over 2, right? 6 pi over 12, that would reduce to pi over 2. We could sort of use that insight because 5 pi over 12, you know, is going to be like a little bit less than that. It's not going to be 6 pi over 12. It's only going to be 5 pi over 12. So, seeing as how 6 pi over 2, or 12 rather, is right here, seeing as how 6 pi over 12 is right here, then you know pretty much that 5 pi over 12 is going to be right there. All right? 5 pi over 12. Now, I'm going to go ahead and just write that because I know that's one of the answers. 5 pi over 12. That's one of the answers. But the problem is the period of pi in this case. We also know that if we did a semicircle, we're going to land on another angle that would also work. So it's going to be like right there. Well, how the heck are we going to find this angle? Well, similar to what we did with the earlier scenario, we can recognize that this angle right here, it's going to be 5 pi over 12 distance from this. All right? It's going to be 5 pi over 12 distance from pi. So in order to find this angle, all we have to do is take pi and add 5 pi over 12 to it, and then we'll be good. Just like before, we have a problem. We don't have that common denominator, so we're going to give it to ourselves right now, making sure to add or multiply 12 to the numerator as well. And what do you do when you have two fractions with the same denominator being added together? Well, you keep the denominator and you add the numerators. So that gives you the other angle right here that is within the range of 0 to 2 pi. So I'm going to write that right now. So when your teacher asks you, what are all the solutions to this equation? Well, the answer to that is, well, all the solutions are 5 pi over 12 plus pi k and pi over 12 plus pi k. If your teacher asks you, what are the solutions to this equation within the range of 0 to 2 pi, well, that would be 4 angles. 5 pi over 12, 17 pi over 12, pi over 12, and 13 pi over 12. All right, so that's how you do that one. All right, so the next problem is sine squared x equals -2 plus 3 cosine x. And let's take a look here. So basically we've got sine squared x, which makes me think of the Pythagorean identity, because obviously the first problem we have to face is the fact that you have two trigonometric functions to deal with. It's always better when you have only one to deal with, or at least most of the time, definitely it's better when you only have one trigonometric function to deal with. There's an immediate opportunity to turn this one into a 1 minus cosine squared x, and then we can set that equal to -2 plus 3 cosine x. And at this point, once again, we have an opportunity to set it up as a quadratic trinomial. So we could, in a sense, add 2 to both sides and subtract 3 cosine x from both sides. And that would give us, we'll keep the 1 minus cosine squared in front at least for now. That would give us plus 2 minus 3 cosine x equals 0. Putting all of this on the left-hand side of the equal sign in order, we would end up with negative cosine squared x minus 3 cosine x plus 3 equals 0. Dividing both sides by -1, which is something that we have done before in this video, would be cosine squared x plus 3 cosine x minus 3 equals 0, for all the previously mentioned reasons when it comes to dividing both sides by -1. And I think probably at this point my student is getting the hang of it, because there's not much else different with regards to this problem when compared to the other problems. The directions do state specifically for this problem, however, to find all solutions in the interval 0 to 2 pi. So we're going to have to deal with that part of it again. It says find all solutions in the interval 0 to 2 pi. So I'm going to assume that that's what they mean just in this range here. U substitution would be a good way to go at this point. So we have u squared plus 3u minus 3 equals 0. Okay, so out the gate, I can immediately see this is not factorable, because when I multiply the invisible 1 here times the negative 3 here, that gives me a negative 3. And there are no factors of negative 3 that would combine to give me a positive 3. So unfortunately, we're going to have to use the quadratic formula. So the quadratic formula is, usually it's written as x equals, but in this case we're going to go u equals negative b plus minus b radical b squared minus 4ac all over 2a. As my student may have noticed before, I'm really big fan of drawing these like empty parentheses and then worrying about what goes in the empty parentheses after the fact. So obviously, you know, the a in this case would be 1, the b in this case would be positive 3, and the c in this case would be a negative 3. So we're going to put all that in there. So we have a 3 here and a 3 here. We have a, 1 here and a 1 here. And then finally we have a negative 3 right here. So that's going to come out to u equals negative 3 plus minus radical. And this part can get confusing, so we're going to do one step at a time. What do we have here? A 9. And then we get focus over here. What do we get when we multiply negative 4 times positive 1 times negative 3? Well, that would actually be a positive 12. So I'm just going to write plus 12. I'm going to worry about that later. Plus 12. And then we have 2 over here. So what do we get as a result of all that? Well, that's going to be u equals negative 3 plus or minus radical 21 all over 2. So we could then substitute, cosine back into it. And we could then write that cosine of x equals negative 3 plus minus radical 21 all over 2. And then I say we bring it all the way up over here. And up there, I would actually like to split this so that it's like cosine x equals negative 3 plus radical 21 all over 2. And we could also write cosine x equals negative 3 minus radical 21 all over 2. Now, focusing on this one first, clearly we're going to have to use the inverse cosine function. So that's going to end up being cosine, inverse cosine of this. And we're going to find out what that equals in a moment, actually. And we'll write the same thing over here since we're on that track. There should be a 1 right there. So it would be inverse cosine negative 3 minus radical 21 over 2. And focusing on this one first, I'm going to use my calculator. We're going to do the inverse cosine of this whole thing. By the way, I recommend the Desmos app for your iPhone for this stuff. So after plugging this one into the calculator, I got 0.658, not the best handwriting, but you can see clearly what it is. And after plugging this one into the calculator, I got undefined. So that basically means that we could totally ignore this, which is really good news. And so let me just erase this actually. And let me set this equal to each other, and we're going to erase this part. So the question is really, what is this 0.658 shenanigans? 0.658 radians. Where would that be? Well, one thing's for sure, we know that pi over 2, if we plug that into the calculator, that's 1.57 radians, where we are looking at 0.658 radians. So we know that this angle right here is somewhere in the first quadrant. All right. Now, it so happens that cosine is such that it's really asking, like basically saying cosine of what angle would give you the x-coordinate of this. All right. Now, this is a positive number. If you were to work this out in your calculator, -3 plus radical 21 all over 2, you would get a positive number. And the fact that this number right here is positive means even though when we plugged into the calculator the inverse cosine of this number, we got one angle. This is the angle x. That's only one of the angles in this range. You know, let's say that 0.658 is like right here. It opens up 0.658. But you know what? We would also get another angle that opens down 0.658 that would also give us an x-coordinate of -3 plus radical 21 over 2. Okay? So this angle would give us an x-coordinate of -3 plus radical 21 over 2 right here. And this angle right here would also give us an x-coordinate of -3 plus radical 21 all over 2. So even though the calculator only churned out one angle, we need to take into account that in the range from 0, angle 0, all the way to angle 2 pi, in that full revolution range, we're actually going to have two angles that would result in that x-coordinate of -3 plus radical 21 all over 2. So we're going to have to take that into account. Okay, so what we're going to do is let's focus only on this guy for now, though, because in a way, we already have one of the answers. It's the answer that corresponds with this angle. So I say we'll just write that answer right now. And that would be 0.658. And that's one of the answers. And we're used to kind of saying 0.658 plus 2 pi k, but since we're only dealing with the interval from angle 0 all the way to 2 pi, we're not going to say plus pi k because that would imply infinite revolutions around, and literally infinite angles that would fulfill this criteria. However, we do have the additional task of figuring out what this angle is. Now, you could kind of call it negative 0.658 radians because it's just going in the negative direction. But another way of going about it is you can think of it as, if you're going to keep it positive, then really what's happening is it's an angle that goes all the way around, and then it stops right there, right? In such a way that it stops just short of a full revolution. And the question is, how short have we stopped from a full revolution? Well, 0.658. And since a full revolution is 2 pi, in order to find this angle, all we have to do is take that full revolution of 2 pi and then subtract away 0.658, and then we'd be good to go. So let's do that right now. It's going to be 2 pi minus 0.658, and plugging that into our calculator, we would get 5.625. So that is the other angle corresponding with this angle right here. So therefore, we could write the final answer as 0.658 and also 5.625. That's how you do that one. Okay, so we have one last problem, and that would be cosine squared x equals 3 plus 4 sine x. And let's see, so very similar to the last problem, only now we have the Pythagorean identity, which would inspire us to turn this into 1 minus sine squared x, for the same reasons that I had mentioned in the last problem. And going through the exact same motions, we would have 1 minus sine squared x minus 3 minus 4 sine x equals 0. Combining like terms would result in negative sine squared x minus 4 sine x. Let's see, 1 minus 3 is negative 2, and we add 0. Dividing both sides by negative 1 would give us sine squared x plus 4 sine x plus 2 equals 0. Substituting u would be u squared plus 4u plus 2 equals 0. Are there any factors of positive 2 that would give us a positive 4 when combined? And the answer is no. So therefore we would need to use the quadratic formula, and I'm just going to get right to it. Negative empty parentheses plus minus radical parentheses squared minus 4 empty parentheses all over 2 times empty parentheses. What goes in here? Well, that would be 4. A is 1, and C is a positive 2. Working this guy out, this would become, let's see, u equals negative 4 plus minus 16, careful with this part, and it would be minus 8, I'll worry about that later, all over 2. And later means now, u equals negative 4 plus minus radical 8 all over 2. And if we want to sort of, suck up to the teacher a little bit, we could always write u equals negative 4 plus minus 2 radical 2 all over 2, and we could even write that as negative 2 plus minus radical 2. Now why is that? Well, that's because this would turn into a 2, that would turn into a 1, and this would turn into a 1 also. So the 4 cancels with the 2, and this 2 also cancels with the 2, leaving a negative 2 plus 1 radical 2, also known as negative 2 plus minus radical 2. All right, that's kind of a more compact, obviously, way of writing what u equals. Now, we both know, or we all know, that u equals sine x. So we could sort of bring that up here. So it is the case that sine x, therefore, equals really two things. Negative 2 plus radical 2, and sine x also equals negative 2 minus radical 2. So clearly we're going to have to use the inverse sine function. We'll do a little divider here. So we're going to have to contend with sine with that negative 1 over it. Negative 2 plus radical 2. We're going to have to figure out what that equals. And also, we're going to have to do the inverse function over here, down below, saying sine with the negative 1 above it of negative 2 minus radical 2 equals. So, doing one at a time, focusing here first, plugging this into our calculator gives us, up here, negative 0.626. And down here it would be undefined. So that means, just like last time, we could ignore this one, which is actually great. However, let's investigate this answer. That's a negative 0.626. So what that basically means is you start here, because when you're measuring, theta angles on the unit circle, you always start here. Now, if it's positive, you're going in this counterclockwise direction. If it's negative, you're going in the clockwise direction. So this is telling us that the angle is negative 0.626. So we start here and we go down 0.626. All right. Now, this, once again, is like 1.5 something. This would be negative 1.5 something. So negative 0.626 is going to be somewhere in this fourth quadrant here. So what I'm going to do is, even if it's not precise, similar to last time, I'm just going to draw some angle in the fourth quadrant. Now, for all we know, negative 0.626 is here or here. I don't care really where it is in relation to these other angles. I just know that it's in the fourth quadrant, because that's all that really matters to me at this point. So it's definitely going down, negative 0.626. So let's be clear, this is one of the answers, because again, the problem is only asking for the range of 0 to 2 pi. Well, this happens to be literally one of the angles that is the answer, because this angle is in that range, right? But I think my student watching probably understands that there is another angle we have to include here that's not obvious compared to, what the calculator churned out for us. And that relies on our ability to recognize that the sine function relates to the y-coordinate of, the unit circle, corresponding with various angles on the unit circle. Now, at the end of the day, this number right here, negative 2 plus radical 2, this number, in other words, this y-coordinate, this is the y-coordinate, by the way, would be negative. So I'm going to write negative y-coordinate. So what does that mean? Well, that means, yes, we have an angle here, but where else do we have negative y-coordinates of negative 2 plus radical 2? It would literally be the angle right here. That is negative 0.626 down from here because of the symmetrical relationship. That would also give us that negative y-coordinate of negative 2 plus radical 2. Because remember, this is the sine of what angle corresponds with the y-coordinate of negative 2 plus radical 2. This y-coordinate is a negative number. You could always check by plugging this into your calculator. It's a negative number. And where do we have negative y-coordinates? In quadrant 3 and quadrant 4. That's where you have negative y-coordinates. Okay? So anyway, we have one of our answers. It's 0.626, but now we have to go on a mission in finding this angle. Now, I think by now my student might be getting the hang of it, but let's make sure we're clear. We're actually talking about the angle that would open all the way from here and land right here. Okay? So all we have to do to find this angle is to basically take into account the fact that we go a distance of pi around, and then we're adding 0.626 on top of pi. Okay? And just the fact that we're going pi around, and then we're adding 0.626, I'm going to just erase this little negative, because I think that might confuse the issue. So the other answer, I'll keep it in red, is going to be pi plus 0.626, and that equals 3.6 0.768. So that's the other answer. Now, we really have two answers, right? We have theta equals negative 0.626, and we also have theta equaling 3.768. Now, I believe that the teacher would be happy with this. However, in my opinion, and this is just my opinion, maybe the teacher would agree, maybe not. It's a little tacky to have one angle represented in the negative with another angle represented in the positive. I would rather both of these angles be represented in the positive. Clearly, this angle is already in the positive, so what I'm going to do is I'm going to convert this angle to a positive version of itself. Now, negative 0.626 is what happens when you start here and then you go down 0.626. Now, if you think about it, it's more than just tacky. In fact, I would insist upon turning this into a positive angle, because now that I'm thinking about it, the problem is asking for all the angles within the range 0 to 2 pi. Well, this is a negative angle, and that's below our range. So we're going to find the positive version of this angle that would be within the range of 0 to 2 pi. So that's actually the real reason to find the positive version of this angle. And that's something maybe I should have said before, but now that I'm thinking about it, we're not going to want this negative version because the range is from 0 to 2 pi. So how do you find the positive version? Well, you could easily see that this angle right here is what you get when you go all the way around to 2 pi and then you subtract 0.626. That's how you get this. So what I'm going to do off to the side, or down here, is I'm going to go 2 pi minus 0.626, and we're going to see what we get as a result of that. We end up with 5.657. So to be perfectly honest, I would turn this into 5.657. And for my final answer, to be honest, I would actually get rid of this entirely, and I would represent the final answer, as theta equals these two. These are the two angles that correspond with a y-coordinate of negative 2 plus radical 2 within the range of 0 to 2 pi. That's how you answer that one.